Hello everyone. We are going to see an important topic, that is lateral displacement of light by glass slab. Lateral displacement phenomena occur in case of refraction of light. When a ray of light passes from one medium to another medium, second medium, and again it passes from second medium to first medium. Here a glass slab is here made, rectangular glass slab. Suppose it is U V W X is the rectangular glass slab outer line. Above to glass slab the medium is air. This is a glass slab, so medium is a glass G, and again it is air. Now see carefully here in the diagram the whole concept of lateral displacement and the factor on which lateral displacement depends here on this diagram. See, consider a point here. At this point take a normal here. At this normal take a incident ray. Incident ray makes angle I with the normal here. Now this incident ray, when it is passes from air to glass, it bends towards the normal. So bending will be take place in this way. This is a refracted ray. And this ray is called incident ray, and this is angle R. See at point, let this point is A, and this is point B. At point B point we are keeping at this place, point B. Here is again ray of light is moving from glass to air. Phenomena refraction takes place here also. So at this point another normal is here. See, these two lines, two normals are parallel, represented by this green dotted line, and a line is intersect, so alternate angles are equal. So in that condition this angle is also R, if it is angle R. When it is moved from again ray of light from denser medium to rare medium, again it's bend away from the normal. Let this angle is E. This is called emergent rays, and small is called angle of emergence. Now see very carefully in the diagram, the two places phenomena of refraction takes place, first at point A and another at point B. Let us apply the Snell's law at point A. Refractive index N, it is moving from medium 1 to medium 2, air to glass. So second medium is glass, first medium is air. So it is angle of incidence I, sin I, by sine of angle of refraction R, represented by equation number 1. Again see at point B, when ray of light passes from glass to air, in that condition the refractive index at point P, refractive index of air with respect to glass is, see, angle of incidence is here, see in the diagram, R, sin R is equal to sin E, angle of emergence here. It is equation number 2. Now see here in the diagram carefully, refractions is taking at 2 places. Let us see the mathematical result obtained by these 2 equations here. First of all, thereafter we will go for the lateral displacement. We are knowing principle of reversibility applied. Light. We have done this topic. Students, we can see the principle of reversibility on my channel Physics Wala. This is available there. You can see in the detail what is a principle of reversibility there. So principle of reversibility speaks that refractive index of glass with respect to air in a 2, refractive index of air with respect to glass is equal to 1. Now putting these values here in NAG, this is sin I by sin R in a 2, and it is by equation 2 sin R by sin E is equal to 1. Sin R is cancelled by sin R, and this implies that sin I is equal to becomes sin E. Again this implies that angle I is equal to, this is angle E. We may write in this angle I is angle of incidence is equal to angle of emergence. This is one of the important result obtained here in the diagram. Angle of incidence I is equal to angle of emergence in case of refraction through the glass slab. Now this is time to see lateral displacement. Seen here in the diagram, one change is here. Proceed the incident ray here forward by the dotted line. In this, according to the diagram. Clear the point here in the diagram. First of all, this is point A, point B, take this is point C, draw perpendicular from here on this line. Let this is point D. Perpendicular unit. This perpendicular distance BD is called lateral displacement. Here, this is it is emergent ray and this is incident ray. The distance between emergent ray and incident ray is called lateral displacement. This lateral displacement is denoted by X. Let small t denotes thickness of glass slab here. Now some attachment here in the diagram. This normal proceed downward. Let this point is N. This is point B. Now some mathematical calculations, see very carefully. In the diagram, let us see very carefully. See the triangle ABD. It is a right angle here. This is I. Here this is I angle, this is R. So this angles becomes only I minus R. We are going to take a right angle triangle ABD. In triangle ABD, see carefully. In triangle ABD, this is angle I. We are going to see the relation between BD and AB. For this, BD is a perpendicular and it is hypotenuse. Then we can write BD by AB is sine I minus R. This is BD by AB is equal to sine I minus R. This is equation number 5. Since BD is lateral displacement, so in equation 5, we may write BD is equal to x by AB sine I minus R here, because since we can write BD is equal to x and this x is a lateral displacement. So lateral displacement x can be given as AB is equal to sine I minus R. We will treat as equation number 6 here. Now this is time to see the value of AB. To see the value of AB, again see the diagram. Point A, B, N. In A, B, N, see N here is a perpendicular right angle triangle. It is angle R. Now we are going to see the relation between AN and AB. For angle R, it is base and it is hypotenuse. So AN by AB refer to the cosine R. So let us see for this in angle right angle triangle ANB. In right angle triangle ANB. Once more see in the diagram. ANB. AN by AB. AN by AB is equal to cosine R. Right? This implies that AB is equal to AN, this is AB is equal to AN by cos R. AN, see in the diagram, AN is equal to thickness of the glass slab T. So this is equal to T by cos R, or one can write AB is equal to T by cos R. It is equation number 7. Now see the mathematical calculation between 6 and 7. We are going to place the value of AB in equation number 6. Putting the value of AB in equation 6 we have. So these equations refer to the x is equal to, this is AB in 2, not equal. AB is what? T by cos R into sine I minus R. Again it can be written x is equal to T by cos R. Sine I minus R, expand by the formula sine A minus B. This is sine A cos B minus cos A sine B. So it's become sine I cos R cos I, 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 Now see here, putting cos r inside, one may write x is equal to t into cos r cancel, this is sin I only, minus this is cos I sin r by cos r. Now see very carefully, we can write, we are going to replace the value of sin r here. So see the trick. We are going to use equation number 1, that is refractive index of glass with respect to air is equal to sin I by sin r. So sin r is equal to, this implies that sin I by NAG. So we are going to place this value here. When we place this value, see very carefully, x is equal to t, sin I is as it is, minus cos I is as it is, by cos r is as it is. In place of sin I, it is sin I by n, refractive index of glass with respect to air. Sin I, we may take common. This is equal to t sin I by 1 minus, here remains only cos I by, what is this? Refractive index of glass with respect to air. Now it is cos r. In place of cos r, we may write under root 1 minus sin square r. Since we know that cos r is equal to under root 1 minus sin square r. So see carefully here in this diagram. The lateral displacement. What is a lateral displacement? See in the diagram. It is x. This lateral displacement here, students, depends on what? The first factor is t, that is thickness of glass slab. One thing, it is a directly proportional. Second, ANG, that is refractive index, and I, angle of incidence. So these are the parameters on which lateral displacement x dependent. This is for the topic. Thank you and have a nice day.